Okay, it's 1 o'clock. Some administrative things first. The homework that was due today, it was all messed up. On the schedule, it said one thing. On the Pearson website, it said something else. I extended that deadline till the end of today. All right, in case you need to go back and tweak any of your answers, that's fine. That's the first thing. Second thing is, I am going to use the camera in the back of the room. That's the best video that I can get, is doing it that way, so I'm going to do that. I'll get this entire board, and I'll try and do that every class, and then I'll post it on YouTube. We're going to cover points, lines, and circles today. If you look at our calendar, Tuesday, August 30th, we're supposed to talk about circles, but I'm going to take some time to review a couple of concepts that we need from points and lines that will benefit you the rest of the way through the class and then into Cal 1. And then we get into circles. I think you will be pleasantly, I guess, relieved a little bit that this is not partial fraction decomposition anymore. I think you're going to feel like this is a little bit easier to swallow here, which is good, okay? I like to start the class with partial fractions because it kind of like wakes everyone up and says, oh shit, you know, my algebra needs to be somewhat decent here. Okay, but we can kind of relax a little bit now and start to get into the trig, right? The trigonometry of the class. All right, so with that said, you owe me a quiz, right? You owe me a quiz, the group quiz that you did in class last time, that you worked together on. I said I would collect that today. So what I'd like for you to do, please, yes? You're each turning in your own, right? Yeah, so just your name's fine, yeah. What I'd like for you to do, I'm going to pass around the sign-in sheet, initial next to your name, and then just add your quiz to the group and just let's get it all the way around. When it gets back to me, all the quizzes should be in here, okay? Got it? There you go. All right. Any questions? Any questions? I'm willing to talk about, not the quiz, but any questions on any homework or... Always bring your homework to class. But I may look at it, I may not, but always have it. I may give you a quiz where I allow you to use your homework. Just always have it with you. All right, no questions? Okay, are you ready? Everybody? Hello? Y'all ready? Okay, let's go. All right, so this is going to be a review of some things that you should know. You've seen, hopefully, in the past, but I think if we just kind of hit the main ideas here, this will help you down the road in this class, like I said, in other classes. So I'm trusting that we're all comfortable with the idea of the XY plane, right? The XY plane. This is called the XY plane. It's called Cartesian two-dimensional space. It's called R2. There's all these different names for it. And here we're just going to look at it as the XY plane. It's a flat sheet of paper that extends in every direction forever, right? All right, so when we look at this, there's a couple of things we need to know. First of all, the point in the middle, that's represented with the ordered pair, 0, 0. That is called the origin, right? Origin. The origin. You get the idea? Okay, that's the origin. And then any point on this plane can be represented with an ordered pair. So if I write this point right here, I can label it x, y. The x is the directed distance down the x-axis, and then the y is the up and down, right, horizontal. Horizontal distance is x, vertical distance is y, right? So we're all familiar with this. It's called an ordered pair. It's called an ordered pair because the order matters, right? If I write this 4, 2, that is not the same as 2, 4, right? Those are two different points. This one is out 4, up 2. This one is out 2, up 4, right? They're reversed. So the order matters, and it's a pair of numbers, two numbers, right? If you go to three-dimensional space, R3, then it's called an ordered triple. And we don't work in three-dimensional space until you get to Cal 3. That's when you start doing everything you learn in Cal 1 and 2, you start doing in three-dimensional space. All right, so we've got that, right? This is all stuff we should be comfortable with. Okay, so the first thing that I want to review as far as things you should be able to compute, if I give you 2 points, okay, imagine I give you 2 points on this plane. Can you find the midpoint? Okay, so midpoint. Something that we should be able to do. So imagine I have 2 points. So this is going to be the xy plane here. I'm just not going to draw the x and y axis. Let's label this point x1, y1, and this x2, y2. So this is the x-coordinate of the first point, the y-coordinate of the first point, the x-coordinate of the second point, y-coordinate of the second point, right? Can you find, is there a formula that allows us to find the point that's right in the middle of those 2 points? So if we were to imagine connecting this with a straight line, can you find this point right here? Well, we can. There's a formula for it, all right? So this point right here, this midpoint, is, anybody know? I mean, there's a formula, you can look it up, but does anyone know, like in layman's terms, how you could describe what it is? No? I think you're thinking slope-ish.
It's x1 plus x2 over 2, you said? Yes.
Right? x2 over 2. And then that's the x-coordinate. And then the y-coordinate is y1 plus y2 over 2. Right? Okay. What was your name again? Juliana. So Juliana, let's say you had 2 test grades and I asked you to take their average. What would you do? You had 2 tests that you took, right? And I asked you to take the average. Add them and divide by 2, right? Isn't that what we're doing here? Aren't we just adding up the x-coordinates and dividing by 2? It's the average of the x-coordinates, the average of the y-coordinates. That's it. Okay? That's a way you can remember it, all right? Questions there? That's a formula. You need to know it exists. You don't need to memorize this. You just need to know it exists. Reference it if you need to. Okay, next thing I want you to be able to do. What about if I give you 2 points? Can you find the distance between the 2? Okay, distance between the 2 points. Now there's a formula, right? Sure there is. The distance between 2 points. So let's say we start with this point. Here's another point, x1, y1, x2, y2. Come on. And we want to calculate the numerical distance. Let's call it lowercase d. If we want to know how long it is, right, that line segment, if we want to measure the length of that line segment, the formula is d equals, we could memorize it, couldn't we? But we could also maybe construct it if we just think about it. If we approach this the right way, imagine that I construct a right triangle from this. Okay? That's not a very good right triangle, but you get the idea, yes? Okay, are we all comfortable with, first of all, the Pythagorean theorem? That says that if you have any right triangle, if this side is A, this side is B, this side is C, that A squared plus B squared is C squared. This will always be with us through this class, Cal 1, Cal. It's just always going to be this thing that we should all know. right? Pythagorean, this is the Pythagorean identity or Pythagorean theorem. So if I knew what this distance was, right? If I knew what that was, and if I knew what this was, then I should be able to figure out what this is. Okay, so let's talk about this. How long is this? So you have to imagine that whatever this value is, think about the x-axis here. Whatever this x value is, that's x1, right? That's this distance. And then when we move over here, this is x2. So isn't this distance from here to here just this number minus this number? Right? So imagine this was 1 and this was 4. Then wouldn't that be 3? Right? If this was a 1 and this was a 4, you'd subtract, take 4, take away 1, you get 3 in there. If this was 7 and this was 10, then you would do 10 minus 7 and get 3, right? So this distance from here to here will always be this number minus this number. So let's put that there. I'm going to draw a different triangle over here so it doesn't look as bad. So this right here, this is D we're trying to find. This is the x2 minus x1. And then this one would be similar idea. What minus what? y2 minus y1. Right? It would be the difference of the y coordinates. However tall this one is, take away the height of this one. Is this making sense, everyone? So according to Pythagorean, this squared plus this squared is this squared, right? So I'm going to write that. x2 minus x1 squared plus y2 minus y1 squared must equal d squared, right? D squared. Pythagorean, applied to that triangle. But we don't want to know what d squared is. We want to know what d is, right? So if I want d, I just take the square root on the left and the right. Right? I just go boom. That'll turn into d over here. This will just be, well, whatever that is, right? And that is the formula. So the formula is, if you look it up in back of a book or something, it'll be, it looks terrible. It's not that bad though. x2 minus x1 squared plus y2 minus y1 squared. There we go. So recap so far, if I give you 2 points, you should be able to find the midpoint. That's the point in the middle of the two. And if I give you 2 points, you should be able to calculate the distance between those 2 points. We good? Questions? I move on. All right. Go here. Let's talk about lines. So in terms of lines, we should all be comfortable with the idea that in the Cartesian plane, if you graph a line, of course it looks like a straight line, right? The formula for this line can come in 2 different forms. You can have y equals mx plus b, or you can have y minus y1 equals m times x minus x1. This is known as the slope-intercept form. I know this is all, I'm just recapping stuff from college algebra here. This is called slope-intercept form, and this one is called the point-slope form. And then there's another form, looks like this, ax plus by equals c, and this is called standard form. There's all these different forms. And we don't need to be all, getting ourselves all, messed up in our heads about which form's which. We just need to really know that when it comes to a line, you're going to have an equation. It's going to contain 2 variables, x and y, that both those variables will be linear, and it'll be an equation. So any time you have x and y connected to each other with an equation, 2 variables, the power on both of those are 1s, you know that that's a line. You need to know that that's a line, all right? The slope of a line, right? The slope is this m right here, right? That's the slope of your line. And so the slope, by definition, is like the pitch of the line, right? The pitch of the line. So let's revisit this. Let's focus in on a line in a little more detail. Let's say we have a line, and let's say there are 2 points on that line. We'll go back x1, y1, x2, y2. All right. So if we have a line and we have 2 points on that line, the slope of this line by definition is rise over run. I know you've all heard that. But in terms of those points, it's always y2 minus y1 over x2 minus x1. Again, that should look familiar to you from college algebra, yes? So if somebody gives you 2 points, 2 points on the line, you should be able to find the slope of that line using that formula. And then once you have the slope, you can use this formula to find the equation. I'm going to do an example so that you can just remember how to do this, right? So far, is this better than partial fractions so far? We're good? All right, so here's an example. Find the equation of the line through these points. -2, 4, and 6, -3. I've given you 2 points, right? 2 ordered pairs, and I'd like to know what the equation of the line through those points is. What's the first thing I'm going to do? Okay, just label these. Call this first one, I don't know, x1, y1. Call this one x2, y2. Okay, and then what am I going to do with that? Find the slope. Okay, let's find the slope of this line. So to find the slope, m will be equal to, okay, here's the formula, right? So what's y2 for us? -3. Okay, take away from that what? 4 over, all right, x2, which for us is 6, and then take away x1, which is -2. So be careful there. There's a double negative, so that's going to turn into a plus. What's the numerator? -7, denominator? 8. That's the slope of your line. So let's see if you remember anything about slopes from college algebra. When you have a negative slope, which way is your line pitched if you look at it like from left to right, the way you'd read a book? Does it go up or does it go down? It goes down, right? That's what a negative slope means. Positive slope, negative slope. What about this? Flat. What's the slope of a flat line? Well, that's a constant. I'm talking about m, right? This m. If your line goes down like this, you're looking at it this way. That's a negative slope, right? Positive slope. No slope.
Slope equals 0.
Slope of 0. Horizontal line has a slope of 0. Think about it. Positive, you have to get to negative, right? How do you go from positives to negatives? You have to go through 0, don't you? So positive, 0, negative. We're just talking about slopes, yes? Okay. So that's 0 slope. What about like 45 degrees? What's the slope of like a perfect 45-degree line? Do y'all know what that slope is? 1. Because it goes over the same amount it goes up. So that's a slope of 1. 0, 1, yes? What's the slope of 2 look like? Is it steeper or is it flatter? Steeper. Slope of 3, steeper. Slope of 10, steeper. Do I ever go over like that? No. okay? The bigger the slope gets, the bigger positive number. Like let's say your slope here was 100. If your slope was 100, it would look almost vertical. If you go to 1,000, it's even steeper, almost vertical. If your slope is 10,000, it's even steeper. Right? If your slope is 1,000,000, it almost looks straight up and down. What about a vertical line, straight up and down? What's the slope of a vertical line? You remember? 0. Very good. 0 is your slope here, right? Positive numbers, bigger and bigger positive numbers. For a vertical line, the slope is undefined. It's impossible to talk about the slope of a vertical line because there is no slope. This looks like it's bothering you all. I'm going to draw a line that's vertical. Okay, there's a vertical line. I'm going to take 2 points on that line. x1, y1, x2, y2, right? What's the rise? Okay, to go from one point to another, you have to rise, don't you? You do rise by some amount. But what about your run? What's your run? Well, you're not going left and right, right? So what's your run? 0. So you're taking a number, rise, and you're dividing it by? You're not allowed to divide by 0. You see? That's why it's undefined. Similarly, if I do a horizontal line, what did I say the slope of a horizontal line was? 0. Let's see why. What's my rise? To go from here to here, what's my rise? Nothing, right? Now, what's my run? Something, right? So if I take 0 and divide it by some number, I'm going to get 0. Making sense? Okay. Sorry, I went off on a tangent there. Finding the equation of the line, gave you 2 points, we found the slope, right? We know that this slope pitches down. But that's not the equation. Here's where we get the equation from, right here. This formula in Cal 1, you're going to see this in your dreams, all right? You use it so much in calculus, this formula right here. So learn it, memorize it. The formula says that if you give me any point, x1, y1, give me any point, and give me the slope of that line, I can give you the equation of it. That's why it's called the point-slope formula. Give me a point, give me a slope, I give you the equation. So do we have a point? Yeah, we actually have 2 of them, don't we? I only need 1 for this formula. And then I need a slope. Well, we already calculated it. So now for the equation, I'll put the answer up here. So this equation is going to look like this. Y minus, what's y1? 4, right? So y minus 4 equals m, which is negative 7 over 8, parenthesis, x, and then minus x1. For us, that's minus what? Minus negative 2. So it's really going to turn into a plus 2. But technically, that is the equation of the line. That's it right there. You could clean it up. I mean, you could solve for y here if you wanted to. And to solve for y, you'd have to distribute this through and then add 4 to both sides and then get it whatever. But I'm just going to leave it right here. So to verify this, I'm going to go to Desmos. So on my graph over there, I'm going to plot the 2 points real quick for you. The points I gave you were negative 2 and 4, or negative 2, 4, that's the first point. Second point was 6, negative 3. All right, I'm sorry that you'll have to turn around, it's kind of a pain, but y'all see the 2 points there? There they are, the red one looks like blue. Now I'm going to tell this, I'm going to type in our answer, y minus 4 equals, was it 7? Why did I put 3 there? Sorry about that. That's an 8. Y'all just say something if I do something really dumb like that. Okay, so negative 7 over 8, and then x plus 2. There we go. See? We've come up with the equation of the line that passes through those 2 points. All right, so if I give you 2 points, you should be able to find the midpoint. If I give you 2 points, you should find the distance between them. If I give you 2 points, you should be able to find the equation through the line through those 2 points, right? All right. We're almost ready to talk about circles. I just want to talk about one more thing. Let's say we have two lines. What does it mean for them to be parallel? Same slope. If I have two lines, what does it mean for them to be perpendicular? Okay, so when it comes to two lines, they are parallel if the slopes are the same, right? If the slopes are the same. So I'm going to put this. If M1 equals M2. What I mean by that is that if you look at the slope of the first line, I'm calling it M1, right? So whatever the line is, it has a slope. I'm going to call it M1. Whatever the slope is of that line, it must be equal to the slope of the other line, the second line. If the slopes are the same, then you have parallel lines, right? Two lines are perpendicular. You've all heard the word perpendicular before, right?
Yeah.
Okay, so perpendicular, I'm just going to put perp here. That's the word we use until we get to calculus. And then once we get to calculus, we stop using perpendicular, or we'll interchange it, but there's another word for it. It's called orthogonal. It's a different word, means the same thing. Okay, two lines are orthogonal. That means they hit like at a 90-degree angle. It looks like a perfect cross, right? What is the relationship between the slopes? I mean, here they have to be parallel, you have to be the same, right? But to be orthogonal, what's the relationship? Anyone know? It's a weird relationship. What did you say? What did you say? One's positive, one's negative. So agree. If one of them is positive, the other one has to be negative. But further, they have to be reciprocals. So the best way to explain this is give you some examples. If the slope of the first one, let's say, is 3, then to be orthogonal, the slope of the other line must be that number flipped over and change the sign. So what would it be? Negative 1/3. If these were the two slopes of the lines that we were given, these would be orthogonal. All right? Give you another example. If the slope of the first line is negative 2/5, then the slope of the line that would be perpendicular would have to be 5/2. That flipped over, changed the sign. Another way you could say this is that, notice this, what happens if you multiply this number times this number? What do you get? What happens if you multiply 3 times negative 1/3? What do you get? You get negative 1. What happens if you multiply negative 2/5 times 5/2? You get negative 1 again, right? That's one way you could say it. You could say they're orthogonal if M1 times M2 is negative 1. If the two slopes multiply to be negative 1, you're looking at perpendicular lines. If the slopes are the same, they're parallel. If the slopes are perpendicular, or if the lines are perpendicular, they multiply to be negative 1. Okay, almost ready. There's one more thing I like to talk about when it comes to parallel and perpendicular lines. If you've had me before, I may have talked about this already. Actually, there's only one person here, right, that's had me before, right? Oh, okay, that's right. Was that Zoom? No, it was Zoom. Okay, so yeah, it's harder for me to relate. Which class? It was the 13, 14, or no? 14. 14? Okay. So maybe you'll be able to recall this. Two parallel lines, right, don't intersect each other, right? That's kind of like the idea. They don't intersect. But do you remember what I said in the beginning of class? We call this the Cartesian plane, right? I called it the Cartesian plane. All the geometry that you learn that you're going to learn here, even in calculus, is based on Cartesian geometry. But there are other geometries out there. It's not the only geometry that exists. So we all agree that parallel lines don't hit each other, right? So the example I like to give is by drawing you a picture of a street. Do you remember this? Do you remember this? No? Here's a picture of, this is a street, and these are some buildings on the side. Pretty good, huh? Right? You see the road, right? The street, the buildings. We're looking kind of from the top down, right? It's pretty good, right? Are all of my rules being followed? Am I following Cartesian rules? Like theoretically, the edge of the road, these are parallel, right? So they shouldn't hit each other. These are parallel, get it? It's not bad. But compare that to this picture. I'm going fast here, sorry. Better, right? I'm tricking your eyeball, right? I'm making you think this is like three-dimensional, but it's actually on a flat sheet of paper, right? Trying to trick you, trick your mind. To do that, I have to break the Cartesian rules, don't I? Lines that traditionally are parallel in the real world, in order to trick you, all those parallel lines have to actually meet somewhere, right? See my parallel lines? They're going to meet at a point way out here. Anyone here who's taken drawing courses, what do we call, or drafting or art or something, know what we call that point? Vanishing point. It's usually on the horizon, right? And then you can draw your little sun here or whatever, right? But the vanishing point is usually on the horizon. Anyone ever do that in drawing? No? Okay, so your vanishing point, notice all things that should have been parallel are actually all meeting at this vanishing point. Okay? This is a different type of geometry. This is called perspective geometry. And the reason I want to share this with you is because we work in Cartesian. Everything we do is in Cartesian. All right? Parallel, perpendicular, all those rules, they only apply to this. If you ever step out of that, you can do other types of geometry. Now, most of you will never see other types of geometry, ever. I didn't see it till I was a junior in college.